Today we're going to start talking about conic sections. Conic sections are created when you take two cones, set them end to end, small end to small end, and then take various cross sections of those figures. In front of you, you see examples of a parabola, a circle, an ellipse, and a hyperbola. Those are the four conic sections we're going to be examining. We're going to start with circles. Algebraically, conic sections are second-degree or quadratic equations in two variables. That means the x variables are squared and the y variables are also squared. This is part of the formula sheet that you will see on your North Carolina final exam in June. This is only the portion that deals with conic sections, and you can see there is information regarding a parabola, an ellipse, and a hyperbola. There is no information on circles on your formula sheet. So the circle, the definition is the set of all points equidistant from a given point or the center. And then in front of you, you see the standard form equation for a circle, x minus h quantity squared plus y minus k quantity squared equals r squared, where h, k is the center, much like the vertex in the vertex form of a quadratic, and r is the radius. So standard form sets that equation equal to r squared. So to find the radius, you'll have to take the square root of that number. So an example. Write the standard form equation of the circle, then identify the center and the radius. So first we need to get all of the variables to the same side of the equation and get similar terms near each other. So I'm going to have the x's first and then the y's. I'm going to have x squared plus 8x. I'm going to bring the y squared over, put the 2y near the y squared, so that the only thing I have on the right hand side is the 64. Now, we need to complete the square. We just have to complete the square with the x variables and with the y variables. So our 8x will be our middle term. Half of 8 is 4, and 4 squared is 16. So we'll add 16 to the left-hand side, and while we're at it, to keep our equation balanced, we'll go ahead and add 16 to the right-hand side as well. Then we have to complete the square with the y variables. So half of -2, which is our middle term, is -1. -1 squared is +1. So we put our +1 on the left side and as well on the right side to keep the equation balanced. Now to complete the square, we'll factor the x terms. We'll also factor the y terms. And when you add the 64, the 16, and the 1 together, you get an 81. So I'll have x and then plus 4 in each set of parentheses, since I have a perfect trinomial. I'll have y with a -1 in each set of parentheses, since I've created a perfect trinomial. And then if I rewrite factor form using a square, I have standard form equation of a circle, where my center is the point -4, +1, because remember in our standard form equation the negatives were included in the equation, and my radius is the square root of 81, which is 9. So there's standard form equation with the radius and the center. The next example is actually a little more straightforward. You're writing the standard form equation of a circle. So if I go back to my original equation, this is standard form. I simply plug in h and k, and square r. So the center, there's h, there's k. So my first set of parentheses, I have x minus h. So that will be x plus 11 squared. My second set of parentheses, y minus k. So that'll be y plus 8 squared. And then since my radius is 4, 4 squared is 16. So there's my equation. A bit more straightforward than the last example. Example 3. Write the standard form equation of the circle. I simply need to know the radius and the center. And since this circle seems to be split by the y-axis, it seems as though our center is at the point 0, 3. And I can count to verify if I go 3 units to the right, 3 units up, 3 units left, and 3 units down, I will touch the edges of the circle. So my center does seem to be the point 0, 3. My radius is also 3 because I could leave the center and go 3 units in any direction and reach the edge of the circle. So then my standard form equation, x minus h squared plus y minus k squared equals r squared, so that will be 9. But this equation can be simplified some because x minus 0 is simply just x. So x squared plus y minus 3 squared equals 9. So once I find the center and once I find the radius, writing a standard form equation is not so bad. Okay. Example 4, write the standard form equation of a circle. So just like the previous example, I need to know what the radius is and I need to know what the center is. I'm given 2 points, the ends of the diameter. So if I go left 17, I'm just going to kind of estimate, and down -9, that's one endpoint. If I go left 19 and down -9, that's another endpoint. So my circle will look something like that. The center of that circle would be the point -18 because that's in the middle of -17 and -19 and -9, since all those y values are lining up horizontally. And then my radius is simply 1, from -18 to -17, or from -18 to -19, that's simply 1 unit. So my radius is 1. So then my standard form equation, x minus h, so that will be plus 18 squared, y minus k, so that'll be y plus 9 squared, equals r squared. And since my radius is 1, 1 squared is simply just 1. And there we are. So just a few homework problems for you to try just to get started. If you'll look at your circles practice worksheet and complete numbers 3, 4, 9, and 10 for tomorrow, you'll be in good shape. Thank you.